Now, graphing a line. Remember, key line graphing is y equals mx plus b, where m is the slope, b is the y-intercept. The slope is always with the x-coordinate, even if these two are flipped around. The y-intercept is always the constant. When you go to graph, you graph y-intercept, and then from there, from the y-intercept, you count the slope to the next point. That is our little review about graphing. You should have remembered from Algebra 1. So when we are looking at this equation right here, if we think about putting our formula above it, if it's minus, I might change that to plus and negative so it matches. So I know my slope is 3 over 1. Remember, constants are always over 1. My y-intercept is negative 1. I'm going to go and graph that. My y-intercept, or intercept, crosses the y-axis is negative 1. My slope is 3 over 1. So I go up 3, 1, 2, 3, right 1. Or I can go down 3, 1, 2, 3, left 1. That's a negative 3 over negative 1, which makes it positive. And this is my line. Now, what this unit is asking us to do is asking us to think about the domain and the range. So you think about what can go into this equation of a line. And what can go into it, the domain is such that x all real numbers. There are no restrictions on what the x can be. It can be any number. If I think about the range, what will come out of this line? Remember, lines go on for all of eternity. And so what is going to come out of this eventually over time? Y such that all real numbers. There are no gaps, there are no breaks, nothing. So I can put all reals into it and I will get all possible reals out of it. Now if I want to figure out if this is a function, I take a quick look to see if it's going to pass my vertical line test. And I think without too much looking, we can see that this very clearly is going to pass any vertical line test we throw at it. So yes, this is a function. Now what happens when what we're asked to graph is a little bit more complicated? When it's something like this, the y squared thing. Well, we don't know how to just straight up graph this. So we are going to use the tried and true Algebra 1 method of a table. And in this case, because this y is squared over here, it's easier to find y values first and then get the resulting x. So if I let y be 0, 0 squared plus 1, that makes this 1. If I let y be 2, 2 squared is 4, plus 1 is 5. I'm going to check negative 2. Negative 2 squared is 4, plus 1 is 5. How about 1? 1 squared is 1, plus 1 is 2. And let's try negative 1. Negative 1 squared is 1, plus 1 is 2. I feel pretty confident that I'm going to see a pattern. Now in this case, I'm going to graph first before I worry about the domain and the range. Whenever I have something that's not a line, and even when I do, I'm probably going to graph it first and then figure out what can go in and what can come out based on the picture. So when I go to graph that, when x was 1, y was 0. When x was 2, y was positive 1 and negative 1. When x was 5, y was positive 2 and negative 2. And so it appears that I'm going to have some sort of a curved shape that does something like that. So now, when I go to think about the domain, and I think about the x values that go into it, there are no x values back here. My smallest x value, my starting x value, is right there. So my x's are such that every x is greater than or equal to 1. Those are the only values I can put in. If I put in negative 4, it won't work. It can't exist. The picture does not exist over here. Now, if I think about my range values that come out of this, what happens? And if I think about over time, this is going to get bigger and bigger and bigger for all of infinity. Eventually, I will get all real numbers coming out of it because there's no limit this way and there's no limit this way to what this eventually can become. Now, my last step asked me to think about the vertical line test, and I think it's pretty clear that it's going to fail. And so this is not a function. Graphing is really the key to see if things are functions or not. Now, our last set of examples is really just substitution. It's a fancy kind of substitution. This f of negative 2 says, well, wherever there was an x in this f thing, it's like a recipe or a set of directions, replace it with negative 2. So I'm going to have negative 2 cubed minus 3. Negative 2 cubed is negative 8 minus 3. The answer is negative 11. It looks complicated, but it's not. Here, I'm going to go to the h recipe right here. And wherever there's a variable, right here and right here, I'm going to replace it with 1.6. So I'm going to have 0.3 times 1.6 squared minus 3 times 1.6 minus 2.7. And if you crank that all out with your calculator, you're going to get negative 6.732. Now, the only thing here, we're going to go back to our f recipe. Be very careful because this is a single number. So we're going to want to use our parentheses. So I'm going to have parentheses 2t cubed minus 3. And if you remember your exponent rules, this means there are 3 of both of these. So I really have 2 cubed t cubed minus 3. So I have 8t cubed minus 3. And that is the end of today's lesson.